welcome to Data Science with Python video series, and today's topic is exceptions and error handling. So when I talk about errors in programming, it's not going to go away from us anywhere anytime sooner. If we are starting learning, then certainly we are bound to make some mistakes, and these mistakes are actually going to help us on making ourselves better programmers or coders. There are two distinguished kinds of errors. So one is syntactic or syntax errors and another are called exceptions. So if I have to explain the syntactic error, so just for an example, if I have to run a loop and I forgot to give an indentation, what would happen is it won't work. So I got the error expected an indent block. So this is a syntactic error where the program knows there is already a problem with the code and it cannot run it. But let's say if I have to do like this kind of operation 1 by 0, then it's another kind of error. There is no problem or there is nothing wrong on writing this particular line, but what was wrong is the kind of a exception which has raised it. 1 by 0 can never be figured out by any programming language so far. So that's why it is called exception now, and it has given what kind of exception we have raised it. So just to understand, when we did a syntactic error, we actually got a kind of a information from the particular programming language, in this case Python. So it pointed me where exactly I have made a mistake and at which line I have made a mistake. And also in the exceptional handling, we got the exceptional error, but actually even computer would not be able to help you on this particular kind of problems until unless it has been defined by the program before. So when we talk about exceptions, errors detected during the execution are called exceptions and are not conditionally fatal for the program. Most exceptions are not handled by programs, however, a result in error are shown. Exceptions come in different types and type is printed as part of the message. So when we did 1 by 0, the exception happened and it gave me a particular type of error which I made. Similarly, if I do this kind of calculation, let's say, I get another kind of exception which says name error, name spam is not defined. So these are very specifically different types which have been defined and it throws when we execute the particular program. Similarly, if I do hello plus 2 must be string not int, so we got the type error. So we have a different set of exceptions for different set of errors. So we just encountered zero division error, name error and type error. Now in programming language they come up with the exceptional handling techniques as well. So right now in Python we have try and except like in any other programming language. So in exceptional handling, it is possible to write programs that handle the selected exceptions. So try and except. So let's say I am writing a function which adds two variables, a very simple function. Now if I do sum of values 1, 2, it's certainly going to give me the result 3 because there is nothing wrong in the argument and the function also expects that. Now if I pass a string and a value, what would happen? It would raise a type error. Now to specifically handle a type error, we can do a try catch block. So how can I do is a simple, I write a try block and I say what actually has to be done. If there is any exception occurs, we get it into the exception and then say whatever message we want to pass or any kind of information we want to pass to the end user. So now if I execute my same command now with the try and catch, if I do, it returns me none. So this is a generic except block which does not care about what kind of exception we are dealing with. It just sees if this can be executable, if not, just finally execute this particular part of the code. Now if I want to specifically handle a kind of exception, as you have seen, zero division error, name error or type error, I can specifically call that particular kind of exception if that exception happens and how to deal with that exception. If I have to deal with the type error, like in my earlier program, I passed the string. So I would write my try block. I would do as expected. If things comes as expected, return x plus y. If exception happen, and if it is an exception of a type error, so type error is a reserved keyword in Python programming language, and hence it automatically accepts it. If a type error happens, this is what has to be executed. So if I run it, now it says, so this has been executed for this particular kind of error. Let's explore another kind of issues. I'm going to modify our function to divide of values, and I will pass xy, and then I will just simply return xy, and still I'm providing the type error as my exception, and I'm going to return please provide integers. Now if I do it, it returns the value. Now if I do 1 by string, it would still work because the exception would be of type error. Now what if I do 1 by 0? It will throw me an error because in my code block, when try got executed, it raised a 0 division error, and when a 0 division error came, we have not written any specific condition for handling the 0 division error. So in Python, we can define n number of exception handlings in our try catch or try except block. So we have a try block which executes the command if any exception happens, except which kind of error happened. So if exception type error happened, then this would get executed. If exception 0 division error happens, this code would get executed. Now if I execute and I do divide 1 by 0, then it says denominator is 0, can't be calculated. Similarly, if I do this name error, now I have to handle this kind of errors which says name error. So as you have seen now, so this kind of experiments can be done. Many number of exceptions can be taken in one try exception block, and so on. We can keep on increasing the exceptions. Now we explored the multiple exceptions which we have seen, so we are good with that. Getting details from the exceptions. So now when we make an error like this where we have not handled, we get a lot of information from our Python backend class. Similarly, we can control those class and can print those errors as how we want as an end result. So similarly, if I execute this particular commands in here, to that exception you can save it as some element. I have just randomly used e, and then you can break it off and then say e.args. So it has all the given detailed info of what exactly happened from the programming language reserved exceptions. So like division by 0 used to occur here. So this is the final message which system has given. So division 0 division error exception happened, and this is what happened, division by 0. And this is what we got to say from e.args or arguments. So far we have looked into the straightforward try and except blocks, and also you can have a multiple except blocks, and finally end with else also. So even if you can have else and then and nothing. So this is how you can have you can have the else statement, and can finally, if nothing exception happened, then you can say a new kind of exception has to be created. Let's go to the next topic. The raise statement allows the programmer to force a specified exception to occur. Now in between, if I want to raise a particular kind of exception, I can just simply use a raise reserved keyword and then call that particular kind of error or exception, and then it just raise that particular or run that particular exception and then stops the code there itself. So if I in the initial itself I'm just calling the 0 division error, and if I call it denominator is 0, still it has raised the 0 division error, as I can see my 0 division error has already been defined. Let's say if I comment it out, it has raised the 0 division error without executing anything else. So at any given point of time, if you find there is a particular need of raising an exception before even executing anything else, you just simply have it and can control what has to be done at that particular execution. So it finally jumped here and simply did what was expected from the zero division error. Then there are certain needs where we need to handle the exception, but still we want to execute the next piece of code in our program. So for that particular part, we have a finally concept in try except blocks. So now our block would be try except and finally. So try would happen, if exception happens it will get handled, and then finally block would be executed no matter what has been done before. In a finally clause, if a finally clause is present, the finally clause will execute as the last task before the try statement completes. The finally clause runs whether or not the try statement produces an exception. In our use case, if we simply take division of values, try, do something, that is return x by y, then if this exception happens, then finally just say, I'm just printing by. And now if I execute it and I do 1 by 0, it raised my denominator is 0, this exception, but also it executed what has been asked at the end. Now I would ask you to think about this particular piece of code and imagine what would happen with this execution. So in my code I have try and then return x comma y and then accept zero division error and then finally. Now in this particular point of time, what would happen? What would be the output? Let's say I divide by 9. It's a fair division statement. Now if I execute it, still it has returned me okay by instead of returning me the actual value. So what happened? If in your try and accept code, if a finally statement exists or block exists and it has a return on that particular block, then this particular block will get executed no matter whatever has been written anywhere. So this kind of things has to be in mind when we are doing a try, accept and finally. So if your finally has a return, this is the only one which gets the priority rather than the try block. And if you observe, in my previous example, I was printing in the finally block. I was not doing the return. This time I did return, and hence this was the one which got executed instead of executing the try block. So if a finally block includes a return statement, the finally clause return statement will execute before and instead of the return statement in a try clause. So far we have covered about systems given exceptions. If you want to generate your own exceptions, it's very simple. You have to just simply use the concept of declaring class and writing it. So here the only thing which has to be keep in mind is your name of the class should have a error name on it. So error, and then it should call exception so that it inherits the properties of the exception. And then just simply I have declared a particular my own exception, got error, and then I'm inheriting the exception, the main class, and then I just simply have this particular statement here. So it's init and it will return whatever will be passed to the particular exception. So let's see how it happens. I have my same example and I am raising got error, and this is the message which I will pass. If x is equal to 1, try and all are same. So this would get passed here. So got error happened, which I had defined, and this is how it came into as a output. So you can explore of your own, based on your own need. You can have your own exceptions. Exception handling is always the critical part in writing codes, because this is how you want to handle if some misinformation is coming through your program, or if some mistakes is being done by the end user while using your programs. This is all for this particular topic. I hope you liked it and you learned it. If you like the contents of my channel, please consider subscribing to my channel, and have a great day.